course atomic model. So at the end of this topic, students should be able to first calculate the IE, ionization energy of hydrogen atom from Lyman series. So specifically for Lyman series. Next, you should be able to state the weaknesses of Bohr atomic model, and then you should be able to state the dual nature of electron by using de Broglie postulate and also Heisenberg uncertainty principle. Next, first, before we calculate the IE of hydrogen atom, you must know what's meant by IE. So, ionization energy means the minimum energy required or needed to remove 1 mole of electrons from 1 mole of gases, atoms, or ions. So, if we write down the unit for ionization energy is kJ per mole, because energy, the unit for energy is kilojoule. Then the unit for, because we calculate the energy required to remove 1 mole of electron. Okay, to remove 1 mole of electron. So the unit is kJ per mole. J is for the energy and mole means for 1 mole of atom. Okay, how do we need to remove 1 mole of electron? Right, for example, if we have a hydrogen atom in the state of gas, so remember this, okay, the ions or atoms, it must be in the state of gases first, right? So if we have hydrogen atom in the form of gas, we will remove 1 electron. So when we remove 1 electron, it will form ion, which is our cation, right? So the equation will be H atom in the form of gas produces H plus H ion in the form of gas plus electron. Right, as we know, okay, ionization energy will always be positive. Must always have positive value. Why? Because we need energy to remove that electron. So that means that electron must absorb enough energy. As you know, okay, for example, we have this hydrogen atom, okay, and this electron, for example, at n equal to 1, right? We have an electron here. Okay, it feels attraction from the nucleus, but now we want to remove, because from Lyman series, right, the ground state of electron for the Lyman series is n equal to 1. So this electron is at n equal to 1. So if we want to remove this electron, that means we have to overcome the attraction from the nucleus. Therefore, we need to absorb energy in order to overcome these attraction forces from the nucleus. Okay, right? Therefore, okay, and initial, okay, if we want to calculate the ionization energy, first we have to calculate delta E first, okay. So you must identify, when we want to use the Rydberg equation to calculate delta E, you must identify n initial and also n final. So n initial, of course, n initial equal to 1 because Lyman series, right? The learning outcome states clearly, okay, you should be able to calculate ionization energy of a hydrogen atom from the Lyman series. Therefore, n initial is 1, is ground state. Okay, start from here, because now our aim is to remove this electron. So that means it needs to absorb energy. Why it has to absorb energy? Because it needs to overcome the attraction from the nucleus. Right? Because nucleus is positively charged, meanwhile electron is negatively charged. So of course this nucleus want this electron, but now we want to produce H plus, so we need to remove this electron. So in order to remove this electron needs to absorb enough energy so that it can move up to the highest energy level possible, so it will no longer feel attraction from the nucleus. So at that time we say, okay, we say hydrogen plus ion is 4, right? So it's going to absorb enough energy, right, up till this n equal to infinity. So n initial will be 1 and final is infinity. So we substitute into the Rydberg equation. So we'll get the value of delta E. So this is the equation. delta E equal to RH 1 over N initial square minus N final square. So initially it is at 1, and initial is N equal to 1, and final is infinity. So 1 over infinity equal to 0. Therefore, the value of delta E is 2.18 exponent negative 7 joule. This is just for removal of one electron from one hydrogen atom. But the question asks you to calculate the ionization energy. And if we refer to the ionization energy, okay, it means that the minimum energy required to remove 1 mole of electron from 1 mole of gases, atoms, or ions. So that means you have to times by the Avogadro constant. Because just now this value is just for 1 atom of hydrogen. Okay, so let's do times the Avogadro constant, get per mole, and then we have to convert it into kilojoule. Kilojoule per mole. So this is the answer. So when the question asks you to calculate the IE, ionization energy of hydrogen for Lyman series, it will always be this value. Because Lyman series always ground state n equal to 1. So n initial will always be n equal to 1. Right? And then n final will always be infinity. So value delta E will be the same. And then we need to calculate for 1 mole of electron. That means we have to times by Avogadro constant, which is also a constant. Therefore, the answer when the question asks you to calculate IE will always be this value, 1312.4 kilojoule per mole. But then you need to know how to calculate this. There are only just 2 steps. First, calculate delta E. Second, times the delta E by Avogadro constant. Very simple. Okay. So next, weaknesses of Bohr's theories. Of course, okay, there are some weaknesses of Bohr theory. The first one, okay, it is unable to explain the line spectrum of atoms or ions containing more than one electron. It is just able to explain the line spectrum of atoms of hydrogen atom, which consists of one electron only. But if we have more than one electron, for example, helium got 2 electrons in its atom, so Bohr theory can no longer explain the line spectrum for helium. So that's the first weakness. The second one, electron is restricted to move in a certain distance around the nucleus of an atom. And it also unable to explain the extra lines. Okay, remember the continuum limit. Okay, so according to Bohr's theory or Bohr's postulate, it is unable to explain the extra lines formed in the hydrogen spectrum. Why? Okay, so we got no answer for this. And then it is also unable to explain the dual nature of electrons. Okay, so as we said earlier, it is only able to explain spectrum line for hydrogen atom but not other atom, because hydrogen atom consists of one electron. But it works for one electron species such as hydrogen atom. Helium plus means its proton number in helium atom, initially the proton number equal to 2, that means the electron also equal to 2, but then when we remove one electron forming He plus, so He plus is going to have one electron. The same for lithium, beryllium. So actually lithium has 3 electrons, but when it forms lithium 2 plus, that means we remove 2 electrons, so there are just 1 electron left in Li2 plus, so it is able to explain for Li2 plus, but not Li plus and not lithium atom. The same up to O7 plus, right? So the limitation of Bohr, okay, later then be explained by de Broglie postulate. So he is a French physicist, suggests that light and matter appear to have dual nature. What's mean by dual nature? That means it is both light and matter. Both light and matter, there are wave light as well as particle light. The dual nature of electron. So this is the equation that de Broglie suggested. You don't have to memorize, but you just have to know what does de Broglie postulate say. So, okay, it says that the electron is actually electron actually have dual nature, which is both wave-like and particle-like matter. Okay, wave-like and particle-like. Okay, so this is, for example, how does, okay, according to the postulate, so this is actually, according to Bohr, the electron is just orbiting like this, but according to De Broglie, it is moving in the form of wave, right? Because light have wave. Okay. And a limitation of Bohr also been corrected by Heisenberg uncertainty principle, because Bohr theory said that electron was thought as orbiting the nucleus, but this would mean that at any moment we will know both the precise location and the precise speed, but this is not allowed in quantum mechanics. This is not the case. So in 1927, Werner Heisenberg states in his principle that it is impossible to know simultaneously both the momentum and the position of particle with certainty. So it is almost impossible. It is impossible. Okay, right? Therefore, okay, this is known as Heisenberg uncertainty principle, which is stated mathematically as this equation. So you don't have to memorize this equation, but you must know that the limitation of Bohr or postulate of Bohr theory, it has been corrected by Heisenberg's uncertainty principle and also De Broglie postulate. Okay? Because De Broglie postulate just now, okay, identify that electron is actually have dual nature. Meanwhile, this Heisenberg uncertainty principle corrected Bohr's theory that said electron is moving in a circular orbit. That means we can precisely know the location and also speed of the electron, but it is almost impossible in quantum mechanics. So, Heisenberg uncertainty principle and De Broglie postulate, okay, brings up to the quantum mechanical model, which is then used, right, to explain about the existence of electrons. So this is what you learn, what are you going to learn in 2.2.